Hi everyone, welcome to my channel, Tutoring Test Prep. Today we will be going over Ottocento number 15, Statistics Conclusions. The goal of the Ottocento course is to teach students everything they need to know about the digital SAT math exam. Please see the link in the description to download this video's worksheet for free. Let's get started. Okay, so quick disclaimer. We are not going to be covering margin of error conclusions, like what the confidence interval tells us, how margin of error affects sample size, things of that nature, simply because we already covered it in Ottocento number 3. So if you want to learn more about that, go check that video out. In this video, we're going to cover every other type of statistics conclusions question you might see. All right, so another quick recap. This was also covered in the Ottocento number 3, population versus sample. So the population of a statistical study is the entire group of individuals we want information about. The sample is the subset of individuals in the population from which we actually collected the data. So take a look at this graphic. So let's say my population is all New Jersey residents, and I take a random sample of 250 people. That would be, my sample would be 250 New Jersey residents. So those 250 people were a subset of all New Jersey residents. Now, when we do these questions today, you're going to see that a lot of the time, they give it to us kind of the reverse. They give us the sample, and we have to figure out what the population is. So let's say I tell you, oh, you got a random sample of 250 New Jersey residents. See how after where they talk about the number, which I don't care about, I underline that? All I'm going to do is take that from the sample and put the word all in front of it, and that's going to be my population. So the population is going to be all New Jersey residents. You're going to see that a lot in the questions that we do. Speaking of New Jersey, did you know that New Jersey is the 11th most populated state with a population of a whopping 9.2 plus million people? And it is the most densely populated state with a population density of 488 people per square kilometer, even higher than Rhode Island. All right, so the ideal survey and the ideal experiment. We're going to talk about what the differences are, but let's just walk through kind of a really basic example. So in a survey, we just kind of ask people something, or it's called an observational study. You could observe them, but you'll see on the SAT that it's often a survey. You ask them a question, right? So let's say I randomly select 150 people, and the study's on like weight loss or something. And we ask each person their weight, what they do to manage their health. We ask them just a bunch of relevant questions, and we analyze the responses. And because we took a random sample, we randomly selected those people, we can generalize the result to the population. Experiments are a little different. We can randomly select 150 people, but then we have to assign treatments. So for example, maybe in this analogy, we're going to assign 2 treatments. One, which is a control where we basically just do nothing to have something to compare to. Sometimes a common control within medical context is to just use whatever medication is currently being prescribed, like the old medication. But you can also sometimes just not prescribe anything. And then maybe we'll assign the other half of people to this new medicine. We want to see if it works. And if in a perfect world, if we did all these things right, we've randomly selected people and we randomly assigned them to treatments, we could generalize the results to the population and conclude cause and effect. Hopefully, that new medicine caused weight loss, and we can use that to make further clinical trials, maybe try to get this medication approved, things like that. So what's the big takeaway? Well, in an experiment, you have to assign or impose treatments to the subjects. If there's no treatments, it's not an experiment. And on the SAT, that probably means it's a survey. A treatment is any condition that is deliberately varied in the subjects of an experiment. So here are some examples. You could have a control, so just whatever we're measuring, like let's say it's exercise, like, hey, don't do anything. Don't change anything about how you exercise. For example, different fertilizers on a field. Different teaching methods. You could prescribe those to different groups of students. Different medicines. And different exercise routines. These are all examples of treatments. If the statisticians are doing something to the subjects, it's an experiment. So here is a big, messy, word vomity table that's basically straight from the College Board. I just typed it up. It's kind of a lot to remember. We'll get to that in a second, but as you can see, right, if we select the subjects, the participants at random, and assign them treatments at random, we can both generalize to the population and conclude about cause and effect. If we don't do one of those things, if we don't select them at random, or if we don't randomly assign the treatments, something gets lost. So you see, if we don't select the subjects at random, we can't generalize to the population, only to the participants in that sample. If the subjects are not randomly assigned, we can't conclude cause and effect. There could have been some other factor based on how we assigned the treatments that actually caused the observed response. So I'm going to make this a lot nicer for us on the next two slides. So here's kind of my shortened survey chart, where G is just generalized to the population, just G for generalize. If your participants are selected at random, you can generalize. If they're not selected at random, you cannot generalize. Remember, we don't assign treatments in a survey, so those other two boxes in the chart are completely irrelevant, so I just deleted them. Hopefully that makes it more clear. You might want to write that down. And here's my shortened experiment chart. So same thing, G is generalized to the population. And CNE is conclude, cause, and effect. So is the treatment, the relationship you're trying to prove, caused by the treatment you gave? And you can see pretty much the exact same information that we covered on the first slide for experiments, but it's just a lot less words. I think this is much easier to look at than all those words in the College Board table. So I don't know, I would write this one down too. Unfortunately, they expect you to know both. Okay, first example. So first things first, I'm checking to see, this is a survey. We're asking them a question, right? There's no treatment. I mean, it says it's a survey, but even if it didn't. And we're going to select, we're going to see if there's a random sample. Did we select the subjects at random? We did. They said it's a random sample. Okay, they're not going to lie to us, so we can take that. So we can generalize the results to the population. That's what the first kind of, the survey table told us. So we're going to look for the population. Remember what I said, guys. We're going to look at what they described about the people in the sample. So the sample, it says that they're runners from Boston. So we're just going to take that, and we're going to put the word all in front of it. So it's all runners from Boston, which is answer choice C. So you kind of see A and D are kind of out just right away, no matter what. Even if it weren't a random sample, like all runners, we didn't ask people from all runners in the world. We only asked people from Boston. And all runners from USA, oh, we only asked people from Boston. We didn't ask people from other states, other cities in Massachusetts. So those are both out right off the bat. It's got to be C. Now, maybe, I've never seen this. It's not really a trick. Maybe the answer would be B if it were not a random sample, because you can, quote unquote, generalize it to the sample. You can always do that. That's not really helpful for a survey because you want to generalize it to a larger group. You don't just want to generalize it to 100 people. It's like, okay, those 100 people work really hard, and it's like that doesn't really tell us a whole lot. So I would keep B kind of in contention, but A and D definitely out just immediately. Great, let's keep going. All right, you can pause this one. Very similar if you want to try it yourself. Pause the video. So, first things first. It seems like we're getting treatments. So the corn plants are getting different treatments. So this is an experiment. So I'm looking to see if it's randomly selected and if the treatments are randomly assigned. Well, it says random sample, so the subjects were selected at random. It's just two different ways of saying the same thing. And randomly assigned, it says that too. So that's all good. And again, remember, random assignment, it doesn't even matter because the question's not asking about cause and effect, it's asking about generalizing. So we don't even really care about if it's cause and effect, but I suppose we could conclude cause and effect as well. So they say it's corn plants in a certain field, so the population is all corn plants in a certain field. So it's B. A would definitely be out. C would definitely be out. Those are just straight up not what they said the sample was pulled from in the question. The 250 corn plants in the sample, it's like maybe if they weren't selected at random, but as you saw, I highlighted in green, they were selected at random, so we can generalize to the population. Remember, generalizing to the sample, especially, this is not a survey, but especially for a survey, kind of useless. We want to generalize to the population. All right, pause this video, take a second to read it. See if you want, you can try this one yourself first. So it says that it seems like this is a survey. We're asking them if they liked or disliked the video. And and again, it's still just asking about kind of generalization, but it's also kind of asking for the conclusion as well. Regardless, first things first, is this a random sample? And it is. It says random sample. Okay, so we're good. And next I want to figure out the population. So the desired population in the study was people who indicated that they enjoyed a certain YouTube channel. Now, sometimes they mess up. Is that actually what we want to extrapolate to? Well, we have to look at the answer choices in A, B, C, and D. So are any of these just kind of sounding wrong? Forget about the conclusion. Are any of these just kind of sounding wrong because they have the wrong population? Well, B, it says people who enjoy YouTube. We didn't ask people who enjoy YouTube. We asked people who indicated that they enjoyed a certain YouTube channel. So there's people who maybe enjoy the platform as a whole or enjoy other YouTube channels that we didn't ask. So whether or not the rest of that statement is right is kind of irrelevant. The population is wrong. Okay, C is also wrong. It says people who watch videos. That is not who we asked. We asked people who indicated that they enjoyed a certain YouTube channel. All right, and D, I think, has a similar issue. It says people who dislike this channel. No, we actually asked the opposite. We asked people who like this certain YouTube channel. So that's wrong too. It doesn't matter if those conclusions, the rest of those sentences are correct. They are not talking about the correct population, so they're wrong. So I already know the answer must be A, but let's check to make sure it has the right population and the right conclusion. So people who like this channel, that's right. Like is just another way of saying enjoyed. So that's similar enough that it's a shortened way of saying what's in the yellow, so that's good. Next, we'll look at the conclusion. So in the question, it says, of those surveyed, 90% said they disliked the new video. And the answer choice says most, so is 90% most? Well, 50% or more, 90% is bigger than 50%, so that's most, so that seems right. And then it says, will dislike the video. Okay, that's what the sentence says. So this seems like an appropriate conclusion to be drawn. So answer choice A is correct. The point here is, guys, we're not just generalizing, we're also making it also, it's not just asking us what population are we generalizing it to, it's asking us what's the conclusion, what's the inference. But you see, right, we could use process elimination to cross out most of the other ones just by paying attention to the population. So that should be one of the first things you try to figure out anytime you do one of these is what's the population of the study? What's the population they want? What population did they actually draw from? Both those questions will help you out a lot. Okay, so we're going to talk about some common design flaws on the SAT for the next couple questions. So one of the most important things, I mean, you'll learn this in any introductory statistics class. It's called a convenience sample. So a convenience sample is when we select individuals from the population that are easy to reach. Convenience samples are very bad because they often introduce bias. Let me give you a very extreme example. Let's say we're doing a survey and we want to ask people if they like ice cream. Let's say I go to a post office, a restaurant, or an ice cream store. Any location would be a problem, but especially an ice cream store, because you can imagine the people who are there already like ice cream. And then I walk in and just kind of randomly select 20 of the people that are there that day and ask them if they like ice cream. I'm obviously going to get skewed results. Probably the population that I wanted to study was like the residents of my town. And just asking people in the ice cream store, that's not a representative sample of the people in your town. So do not just select your subjects because they are easy to reach. That's not going to give you good results. They need to be truly randomly selected. We'll talk about that more in a sec. So, two common things they hope you'll just kind of miss is that they'll select the groups of names from a list in order, or they'll select the people based on some kind of irrelevant trait. And both of these are bad. That is not random. So, for example, if I have all the residents of the town, let's say sorted by alphabetical order, and then I pick the first 100 names on the list, it's like, oh, that doesn't seem like that big a deal, right? Okay, but like, what if, like, I don't know, like, people with the last name that starts with letter A or B, they happen to be of a certain income or certain race or ethnicity or something like that. It's just not random. It's not good study design. It seems like it's not a big deal, which is why they use it in trap answers, but it is. You don't want to do that. Okay, another example is like if I said, hey, I'm going to select the 50 best performing athletes and the 50 worst performing athletes to do a study on some sport. That doesn't make sense. I'm leaving out so many people in the middle that probably make up a very large percentage of my population. That's not random as well, so that is not good. Another common problem is this is also kind of a convenience sample in a way, is you survey people who volunteer to survey, so to participate. So a common example of this is like, I'm on the radio show, and I ask like, oh, call in now. Do you like this radio? Do you like our radio show? And like, everyone who calls in is going to either love your show and just want to be featured, or they're going to hate it, right? It's like you're going to get very polarizing results from that. So you want to select your subjects at random. So how are we going to do that? Well, the most classic way they teach you in school is like, oh, put all the names in a hat, and just shuffle it, and just keep picking names until you have how many you need, 100, 50, 200, whatever. Something you'll see mentioned on the SAT is what's called a random number generator. So you could assign all the potential participants a number and then use a computer to randomly select them. That's really good. That's like going to be totally random. There's no human bias there. And again, as you guys kind of noticed in the previous problem, sometimes the question just tells you they were selected at random. So that's good too. That's good enough for us. SAT's not trying to trick us there. They're not trying to lie to us. If they tell you it's selected at random, then it is. All right, let's look at some problems. Pause this video, try it yourself if you want. So we've got Well, there's a lot going on with this one. So first things first, it says we want the opinions of all city residents. So that's the desired population. That's the goal of the study. But let's see if they asked the correct people. So if you look where it talks about the sample, the population that the sample is drawn from is all city residents who are athletes. So that is not a representative sample for what we're trying to do. So that is not good. I definitely think this one has a flaw. So let's look at the answer choices. First one's definitely out. We didn't even choose the correct population. So we can't make a conclusion about it. Let's see. B says should have included more residents who are athletes. No, we should have just included city residents. That's what the city council wanted to assess. So that's no good either. C says it should have consisted entirely of residents who are not athletes. Okay, that is also not good. Again, the city council doesn't care about that. They want to know about all city residents. So that doesn't sound good either. Again, you could imagine with like tennis and swimming, like the person being an athlete or not an athlete is going to like skew how they feel about it strongly. So this is a really extreme example. Both of these would give us bad results. So the answer is D. So bias just kind of means there's poor results. It's flawed. It's kind of swung artificially one way. Probably the athletes are going to vote in favor of getting the new swimming facility, whatever. When maybe the whole town doesn't necessarily think that. And this part here, it says not representative of all city residents. That is true. We talked about that at the beginning. The city council wanted all city residents, but we asked city residents who are athletes. It's not representative of the population that we want to actually poll. All right, pause this video if you want to try this one. So there's not a whole lot going on in the question. It just says, which of the following methods of choosing, so your selection, your sampling, would result in a random sample of viewers? Okay, so taking volunteers, we talked about that. That's a red flag. So not only are we taking volunteers, we're taking the first 100 volunteers. So that's like two irrelevant things that we don't want. The people, by the way, guys, this is essentially what you do when you make a YouTube community poll. So you have to be very careful about interpreting those results because the most active people don't necessarily speak for everyone. But I digress. We talked about volunteers is bad. Taking the first 100 off a list, that's also bad. So this has a double whammy. A's out. Okay, sorted alphabetically, that's another irrelevant trait. That's not random. Sorted alphabetically is not random. And again, we gave it to the first 100 viewers. That's just pulling off a list in order. Even if it weren't sorted, we probably shouldn't do that. We should probably randomly select them. Okay, C says obtain a numbered list and then use a random number generator to select 100 viewers. That sounds good. That's one of the good methods we talked about on the previous slide. I bet the answer is C. But let's look at D. All right, it says attain a list of all viewers who are attending an upcoming live stream. Okay, so that sounds like a convenient sample. We're just reaching them because they happen to be at the live stream. And once again, we're giving them to the first 100 viewers on that list. That is a double whammy. We don't want to just mindlessly read off a list, and we don't want to select them based on some characteristic that does not matter, that we don't want to skew the results. So we don't want to just pick people at the live stream, just like we don't want to pick people at the post office or the ice cream store or a restaurant. It's not representative of the population we want to reach. We want to reach all viewers. And C is the only one that's going to do that and do so randomly. Okay, so some common problems with experiments. So good experiments usually do the following. They keep all factors aside from the treatments the same. They have more than one treatment, right? If you just have one treatment, what's the point? You can't conclude cause and effect. You have nothing to compare it to, right? You usually have a control, which is like no treatment, or like I said, some kind of baseline of like how things are normally done. So like, I don't know, for example, like what medication is typically given at the hospital for this condition? Or like, oh, if someone broke their leg, it's like, okay, they typically are put in a cast for 6 weeks or something. Compare it to whatever is the standard treatment. So either no treatment at all or whatever the standard treatment is. And again, you can have more treatments as well, but you at least got to have 2. And the treatments, as we talked about many times, have to be randomly assigned. Otherwise, you can't conclude cause and effect. So here are some examples of each of these flaws. So let's say in the weight loss example, in addition to giving medicine, we also varied the amount of exercise. Okay, that's two things we're varying, two factors we're varying. We don't know if it's the medicine causing the weight loss or the exercise causing the weight loss. So we shouldn't do them at the same time. Yes, as you get into higher level statistics courses, there's probably ways to make experiments with like tiered types of treatments, but you're never going to see that on the SAT. So pick one thing you want to vary and only vary that one thing. So either just vary the medicine or just vary the exercise. Do not vary both at the same time. B, do you remember my example? It said like give 75 patients nothing and then give 75 patients the medicine. What if I gave 100 patients, or I guess in that example, 150 patients, the medicine? That would just be one treatment. There's nothing to compare to. That's not a good experiment. How are we going to interpret the results if we don't have anything to compare to? That's a terrible idea. We need to have we need to have more than one treatment. All right. And the last one, let's say if instead of randomly assigning study plans on an educational study, I gave one study plan to all the students in one class, and I gave the other study plan to all the students in a different class. Well, there's lots of factors that make them different, right? In particular, they both have different teachers, so maybe it's not really the study plan that's determining their success. It's maybe more the teacher and classroom environment that they're exposed to. So that's not random assignment. All right. So, did you know that New Jersey is lovingly called the Garden State by those that reside there? However, my friends who live out of state negatively call it the armpit of America. Maybe because it's like kind of smelly from like the pollution from New York City. But also because, it kind of looks like an armpit if you look at kind of where it is on a map. However, you'll be surprised to hear that U.S. News actually ranks New Jersey 32nd in terms of pollution. So they're not even in the 10 worst states. And if you go look up what those 10 worst states are, they will surprise you. A lot of them are very rural, low populated states, probably with lots of industrial pollution. All right, pause this video and try this problem if you want. I think all these are experiments. So, we're looking for 2 things with experiments, guys. Do we have random sampling and do we have random assignment? So, the thing that jumps out to me first here is that it says the seeds from one package were given fertilizer, and the seeds from the second package were not given fertilizer. This sounds a lot like the school example. That doesn't sound like random assignment. So that's a problem. And do you notice the question says whether the fertilizer has an effect? Can you deduce cause and effect in this experiment? So they don't really care about the generalizing. their question is asking about cause and effect. And remember, cause and effect is determined by, do we have random assignment or do we not? So we don't have random assignment. So we can't conclude cause and effect. So we got to change it so that it does have random assignment. Let's look at the answer choices. D is out. We just said a change needs to be made. Oh, this answer choice says randomly assigned. It straight up says it. So that's the answer. And notice how it says half of the seeds from each package should be randomly assigned to each soil type. That makes sense because then you'll have kind of an even blend of the seeds from each package getting the fertilizer, getting both treatments, right? Might seem like a silly thing, like, Kyle, oh, what's the difference between two seed packages? Who cares? What if one of the seed packages is a dud and has many dead seeds in it? You might associate that with the absence or presence of the fertilizer, when really it was due to your poor experimental design. Answer choice A is wrong because this is actually worse, right? This is worse than doing nothing. We're basically making another uncontrolled variable. So we're essentially having two treatments, right? Like two factors that we're varying. Remember, we said not to do that. We only want to vary one factor, in this case, the fertilizer. So we want to keep everything else constant as close as possible. So A is wrong because of that. C is wrong because, as we talked about, if you only have one treatment, if you only give one treatment, how are you going to compare? How are you going to conclude cause and effect? You have nothing to compare it to. You need some other group to serve as a baseline, whether it be you do nothing to it or you use what's commonly being used in that situation. For example, maybe they could just go buy some old fertilizer from the store, whatever's run of the mill. Great, let's keep going. All right, we got another experiment here. Again, pause the video if you want. Attempt the question yourself. All right, so let's see. We're looking for, it's an experiment, so we're looking for random sampling and random assignment. So the population is all people with inflammation. They tell us that. That's great. Were they selected at random? Well, they were. Question says that. And were the treatments randomly assigned? Yes, they were. Okay, so this is literally the ideal experiment. The top left box in that chart I made for you guys, we can both generalize to the population and conclude about cause and effect. Okay, so it says, based on this, which of the following is a appropriate conclusion? And they tell us what the results indicate. Most participants saw improvement, significantly reduced inflammation. Okay, treatment Q is the most effective treatment available. That sounds incredibly extreme. And just like the reading section, guys, if an answer choice is too extreme, too certain, like we can't say any of this with any kind of certainty. We just think, oh, it's likely or it's plausibly the case. Like when we did Ottocento number 3. So A is just way too extreme. That one's out. B says anyone. Okay, so the population in B is anyone, any person who receives treatment Q. And that doesn't seem right. It says that the population is all people with inflammation. So that doesn't even have the right population. So B can't be right. Okay, C says treatment Q is likely to reduce inflammation. Okay, that sounds pretty similar to the end. But let's look at the second half. Oh, it says in people without inflammation. Oh, no, the population in the study was all people with inflammation. So that's not right. So it's got to be D. Treatment Q is likely to reduce inflammation. That's the conclusion the results found. And the population we're going to extrapolate that to is all people with inflammation, which is in answer choice D. So that's our answer. All right, last thing. One other type of question that caught my eye that we kind of talked about in the basic statistics video, so that's Ottocento number 9, is outliers. So, if a question tells you the mean is greater than the median, remember in the basic statistics video, we talked about how outliers significantly change the mean as opposed to the median, where the median either stays the same or it just changes a little bit, whereas the mean is heavily affected by the outlier. It's pulled towards that outlier. So if the mean is greater than the median, a plausible conclusion you can make is that there are a few big outliers, so numbers that are much bigger than the rest of the data. And if the mean is less than the median, there are probably a few smaller outliers pulling that mean down. You might want to write this down. Again, we covered this concept very similarly, but we did problems with like numbers and stuff in Ottocento number 9. Now we're going to do like an actual conclusions question where it's mostly just words. All right. Okay, so it says we got a median price of $50. And we've got a mean price of $110. And notice how it says, which of the following situations could explain? So there's probably other reasons that could explain it. It's not saying it has to be this. It's just saying this could explain the difference between the median and the mean. Well, it seems like the mean is much bigger than the median. And B and D are out. D, I don't even know what D is saying. Like we were just missing some data points. Okay, maybe that could cause this, but that doesn't seem like the most plausible explanation. And many of the games are valued between 50 and 110. I don't know. That doesn't really seem super reasonable either. The mean and median would probably be closer together. And as a matter of fact, you probably wouldn't have a median of 50 if many of them were between 50 and 110. The median would probably be bigger than 50, so it kind of just doesn't make any sense numerically. All right, so let's look at A and C. That's what it's in between. So A is saying a few games much less. So he's basically saying there's a couple small outliers, which would mean that the mean is less than the median. However, as we were just talking about, the mean is bigger than the median. And that's what answer choice C is suggesting. So we're going to go with answer choice C. There are a few games valued much more. That's just an in-context way of saying there are a couple of big outliers, points that are much bigger than the rest of the data values. Okay, it's time for the final review. Remember to download the free final review worksheet using the link in the description. Try to complete the worksheet yourself before watching the rest of the video. And I highly encourage you to ask relevant questions about this topic in the comments section. Let's jump to the whiteboard for the final review. Okay, question 1. So I see that the question says we asked them their personal best, so we didn't assign any treatment. We just asked them a question. So this is a survey. Now I'm thinking really all I care about for surveys is were the subjects selected at random or were they not? And it says here we got a random sample. That means they were selected at random. So the first table tells us we can generalize to the population. Now we just got to figure out the population. So we kind of look at where it's talking about the sample, and we just kind of chop off that number because that's our sample, and we put the word all in front of it. So the answer to this one, I don't even need to read the answer choices, is going to be something like all amateur weightlifters from New York City. And that is answer choice D. Looking at the other answer choices, providing it was selected at random, we're not going to just generalize to the sample. We generalize to the population, so A is wrong. B is all weightlifters, but we didn't ask all weightlifters. We only asked amateur weightlifters from New York City. And C says all professional weightlifters. We didn't ask professional weightlifters. We only asked amateur weightlifters from New York City. Great. Okay, question 2. So we got another survey. And first thing, all we care about surveys is were the subjects selected at random? And it says right here that they were. And now we're just looking for the population. And we don't even need to extrapolate it from the sample. This question, they just told us the population, literally verbatim in the question, all high school students in the county. So that is the answer, C. Great. Okay, question 3. So, we're not really asking a question in this one. This is more of I would say it's less of a survey and more of an observational study. Again, guys, remember what I said in the lecture? If you get confused, just try to think, were there any treatments assigned? And if you read this paragraph, you're going to see that there's no treatments assigned. It's just people playing a game, and we're just analyzing the results. So there's no treatment. We didn't tell them to do anything. We didn't interfere. So it's a survey, or at least an observational study. Same idea. So all we care about, are they selected at random, so that we can generalize to the population and what that population is. So were they selected at random? Well, it says in the question, selected at random. And it says from all Rocket League teams in a certain tournament. It just verbatim says the population. Nothing about this table matters. Really, all we were looking for to see is if it was selected at random and how we can generalize. So let's look at the answer choices. Okay, so it might seem like deceptively easy, but I believe the answer is this one, all Rocket League teams in the tournament. That's just the population that we extrapolated from the question up here. Let's maybe talk about why some of the answer choices are wrong. In the sample, that's a red flag. That is always wrong. We selected a random, so we generalized to the population, not the sample. It says all Rocket League teams in the tournament that scored 13 or more goals per round. Okay, so they weren't even like filtered that way. I believe it was filtered based on at least 2 Demolition Brown, which I would maybe think about that being right. It still wouldn't be right, but at least that would make more sense. So this is just like, this part sounds good, but this part down here definitely wrong. And let's look at B. B says in the sample. Okay, we don't generalize to the sample, we generalize to the population. So yeah, this table, guys, they didn't ask us to, there's no conclusion, they didn't ask us to, there's no inference, they didn't ask us to interpret the results from the table in any way. It's just asking about what the population is. That is it. Let's keep going. Okay, question 4. This is another survey. So once again, all I'm looking for is, were they selected at random? And then if so, what's the population? So let's see here. It does say it was a random sample, so they were selected at random. So that means, based on the first table, that I can generalize to the population. Now I'm going to try to figure out the population. So it says of 1,600 people who indicated that they disliked a certain standardized test. Remember, we're going to kind of chop off that number. And for the population, we're going to put all, kind of like my example in the slides, 250 New Jersey residents versus all New Jersey residents. Okay, and it says that the majority of them liked the new digital format. Okay, so let's look at A. This says people who dislike standardized tests. That's not the population. The population was people who indicated they disliked a certain standardized test, not all standardized tests. So that is just wrong right off the bat. And it also says at least 75%. We don't know that either. That is really bad. Remember when we learned about margin of error in episode 3, we talked about how it's like a swing, right? So really a better word to put here would be like, so let's say the margin of error were 3%, it could be 72% to 78%, something like that. So maybe a better word to put here would be like approximately 75%, but again, it doesn't matter, the population's wrong, so. Okay. Most people who dislike people who dislike this standardized test. Oh, that sounds good. And then it says most is 75% most. Well, most would be like 51% to 100%. Can we confidently say that 75% with like a couple percentage points margin of error is most? Yeah, I think we can. So most will like the new format shown. Okay, that's what they shown. I'm thinking the answer is B. Let's look at the other answer choices. Okay, this is people who dislike this standardized test. That's the right population. But then it says 25% of people will dislike the new format. Question didn't tell us that at all. The survey was probably not necessarily binary. There could be like, maybe it's 75% liked, 25% liked, and then 5% said no opinion or something like that. So we don't know that 25% said that. And there's already an answer trace that's way better anyway. So so this is wrong. Yeah, I would not try to get fancy with the question. They're not trying to trick you. Again, like I said, there could have been more options on the survey that the question maybe didn't specify. Maybe it could have worded that a little bit better, but I digress. It does say they liked or disliked, but perhaps in the actual options, there's something like prefer not to say or neutral, something like that. And notice how it says 25% of. That's too definite. It should say approximately, something like that, right? We can't like too extreme of an answer, so it's still wrong for another reason anyway. All right, most people who like this standardized test. Okay, red flag here. People who like this standardized test. That is the wrong population. We said it's people who dislike this standardized test, so that one's wrong too. Great, let's keep going. Okay, question 5. This is just asking us about how to get a sufficient random sample of residents of the rural town. Tell all residents that volunteers are needed. I don't even need to read that. I don't even need to read the rest of it. That's wrong. Obtain a numbered list of all residents. Okay, that sounds good. And then it says use a random number generator to select 30 residents from that list. That sounds good. I think the answer is B. Okay, so C is kind of tricky. C has some good stuff in it. For example, it says assign each of them a number. And then it says put all the numbers on a slip, slips in a hat, and then shuffle it. That does sound random. That sounds like actually classic, perfect, small-scale random selection. It's probably what you'd do in your class to like dole out responsibilities for like cleanup or something, right? So that actually is pretty good. However, there's some other problems with it. See how it says each diner. We don't care about the diners. We want to know the residents in the rural town. Someone could totally be, sitting at the restaurant and just be from a town over visiting their friend or something, right? It's like you could drive 20 minutes to go to a restaurant in another town. The other thing is just kind of the nature of pulling them from the restaurant. That's called a convenience sample. We talked about that in the video. That is really bad. You never want to do that. It sounds silly, guys, but maybe people who go out more or at the restaurant at that particular time or at this particular restaurant, maybe they have some kind of political leaning or something like that, and it's going to skew the results. So this is wrong for because we're picking people from the restaurant. That's not good. It doesn't matter that it's unrelated. It seems unrelated to the election. It's not a random sample. Okay, D. D is also a convenience sample. We've got, again, this whole, just rattle down the list, pick the first 30 on the list. That is not good. And also it says attending an upcoming fireworks show. That is a convenient sample. Maybe people are going to lean one way or the other. The people who are at the fireworks show. I don't know. Again, not the point. It's not a random sample. B is the only one that's going to give us a truly random sample. Let's keep going. Question 6. Okay, so we've got 40 restaurants, chain restaurants, in different areas throughout a state. Okay, so maybe these locations differ by some kind of factors like pay and cost of living and stuff like that. So that's kind of important. And it even says he thinks job satisfaction varies greatly from location to location. That's also important. And we want to get the proportion of all employees of the restaurant chain who are satisfied with their job. Okay, so one that's jumping out at me right away is wrong is B. So see how it says surveying the 20 highest paid employees and 20 lowest paid employees. That's like a big no-no, and we talked about that in the lecture. That's going to give you incredibly skewed results. The people, the 20 highest paid are going to think it's the best place ever, and the 20 lowest paid are going to think it's the worst place ever. You're not capturing like the vast majority of your workforce at all. It's not a representative sample. This is really bad. That is wrong. That should jump out at you. Notice the word random isn't in there at all, right? That's another problem. Okay, so C says create a website on which employees can express their opinion. So it doesn't directly say it. First of all, using the first 40 responses, that should be like, just as we talked about, just going down a list. That is wrong. That is bad. Like the people who promptly fill out the survey maybe have better things or worse things to say about the company than the people who do it later, right? It doesn't directly say it, but a website on which employees can express their opinion. That sounds an awful lot like volunteering. And remember, we said volunteering for a survey is really bad. We want to randomly select the participants. Okay, so now we're between A and D, and they both have the word random in it. And that is good. Both of them seem kind of convincing, right? But you'll kind of notice there's a big issue with D, and that is that it says selecting one of the 40 locations and then surveying all the employees at the location. So you're not gonna get any of the employees from all these different areas that the researcher is concerned about, right? Let's say we pick the location that's like in a really good place to live or something, and all the people say, oh, working here is great. It's like, I can afford my rent, afford my groceries, everything. But then like all the people in the other locations are like, listen, I'm barely getting by. This is awful. That's going to obviously skew the results. So you kind of want people, you're not capturing all employees, you're just capturing employees from that one store. And this one does a much better job of accounting for that. So we're going to do 8 employees, hopefully some kind of proportional amount from each location, and then surveying all of those. So A is the answer. Does a way better job of accounting of capturing all employees of the restaurant chain, and for accounting for those kind of differences in geography and location that the researcher is concerned about. Great, let's keep going. Okay, question 7. So this is a poll, which is just essentially just a type of survey. We're just asking a question. And you'll notice there's a lot of problems with this poll. In particular, you may notice there was no random sample. So remember, that means we can't generalize to the population. If we don't select the participants at random in a survey, we cannot generalize to the population, which is kind of what the question's asking about. And you see this big red flag. This jumps out right. Host invited listeners. That's just a fancy roundabout way of saying they were volunteers. They volunteered to do the poll. That is really bad. The people who volunteer maybe have particularly good things to say about the show, or bad things to say about the show, or whatever was being discussed. Okay, and it says it's also asking them after the show, and it says that 76% responded yes, 18% responded no. Okay. All right, let's look at the answers. The show did not allow viewers enough time to respond to the poll. That's irrelevant. No idea what that's talking about. Remember, we just talked about kind of the idea is we need a random sample that represents the population of the United States. That's what we want. Okay, B. Those who responded to the poll were not a random sample of the population of the United States. Oh, that sounds good. Yeah, they were just volunteers from the radio show audience. That is exactly the problem we were just talking about. Okay, this one says the percentages do not add up to 100%. That doesn't make any sense. As we talked about, there might be some third or fourth or fifth option that just wasn't really worth mentioning in the paragraph. Like 2% said don't care or something like that, right? People are often just gonna, in something informal like this, gonna leave that out. It doesn't really matter. Certainly doesn't explain our question anyway. And the host discussion of the bill did a poor job of highlighting, okay, this is really bad that the people voting listened to someone's thoughtfully curated opinions before answering the question. That is really bad. Oh, if the radio show host did a good job, maybe presenting the positive benefits of the bill, lots of people are going to say they agree. So that introduces bias. Great, let's keep going. Okay, question 8. This one is definitely a experiment because we've got treatments to assign, right? So when we look at experiments, as we talked about, we're looking for were they randomly selected, which isn't always practical in real life because you can't just force people some new treatment, and we're looking for a random assignment. So let's see, they were selected at random, and they were randomly assigned treatments, and they were given at least 2 treatments, one of them being a control, the placebo, the sugar pill, and then the other half received the new drug. That seems pretty good. Okay. Now I suppose we should look at what the population is. At least they straight up told us. That's convenient. People with headaches. All people with headaches. Okay. And then it says the results indicated that most participants who received treatment Z experienced significantly worse headaches. Most participants, their headaches got worse taking the new drug, possibly due to a side effect, based on the design and results of the study, which is the following conclusions. Okay, treatment Z. Okay, right away, I'm just going to check the populations. That seems like the easiest way to go about this. People without headaches, that's not our population. Our population is people with headaches. I don't even care what the rest of this is saying. It's wrong. This one says anyone. So that means people with headaches, people without headaches, etc. Again, it's not our population. Our population is just people with headaches. So that's out too. Treatment Z is likely to worsen headache in people with headaches. Okay, people with headaches, that seems good. Likely, not extreme language, right? That seems good. And then it says most participants got worse headache. So likely to worsen headache. That sounds good. I think it's C. Let's look at D. Treatment Z is the least effective headache treatment available. It doesn't say anything about the population or the conclusion, just extreme language. Definitely not right. Remember, we're looking for words like most, likely, approximately, plausibly, things that are not too definite because, statisticians can't predict the future. Great, let's keep going. Okay, question 9. We've once again got an experiment. It doesn't really mention random selection, but random sampling, but fortunately, kind of the question isn't really asking us about generalizing, so we don't really care. The question's asking us about cause and effect. Remember that second table, cause and effect. Conclusions about cause and effect is determined by solely if you randomly assigned the treatments. So the question is, did we randomly assign the treatments? Well, it says the student from one class were given the old standard study plan, and the students from the second class were given the new study plan. That sounds like sorting them based on some irrelevant characteristic. That's not random, right? What if one of the classes had a way better teacher or something like that, or different curriculum, different textbook? I don't know. So, so that is no good. So we don't have random assignment. So we need to pick an answer choice that accurately describes random assignment. Well, I'm kind of seeing here it says straight up randomly assigned. And I know that's a little on the nose now that we've gone over it, but that is the answer, right? You kind of want to get a proportional amount from each kind of like subgroup to each treatment. So that way it's like an even blend of people. So let's say, for example, a medication has something to do with like men and women, like, and you have like so many men and so many women, like you would give each treatment 50% of the men get one treatment, 50% of the men get the other treatment, and then 50% of women get one treatment, and then 50% of women get the other treatment. That way, you're kind of accounting for the differences between those two types of people in your results. Okay, let's talk about why some of the other ones are wrong. This is just irrelevant. They should be given 5 additional hours to study per week. That's actually going to skew the results. Maybe it's like maybe the extra study time would make the old study plan seem better when it's not. All 50 students should receive the new study plan. We talked about that. You need to have 2 or more treatments. So you have something to compare to, right? Just giving everyone one treatment, it's like, who are you gonna, there's no one to compare to, right? You need to have some kind of baseline at least to compare. And then it says the 25 highest achieving students should receive the old study plan. That sounds really bad because it's going to make it seem maybe like the old study plan is really effective when it's just your poor experimental design. So that one's wrong too. Great, let's keep going. Okay, last one here, question 10. So this is another kind of like outlier conclusions question. I'm going to try to do it kind of without looking at the answer choices. So the median is 750 and the mean is 500. Okay, so the mean is smaller than the median. So that means there are a few small outliers pulling that mean down. So I'm going to look for an answer choice that just kind of sounds like there's a few small outliers in context. And I'll fix this in the worksheet, guys. It should say paintings. All right. Let's see. There are a few paintings valued much less than the rest. That's what we want. So we've got a few small outliers, much less than the rest. So this is correct because this is saying mean is less than median. That conclusion would explain that. C is basically saying paintings valued much more than the rest. The mean is greater than the median, which is not what we had. The mean was $500. The median was $750. So that's out. B is just super off topic. As a matter of fact, if the paintings were mostly, if like the vast majority of them, like 90% of them were between 500 and 750, the median probably wouldn't be 750. It would probably be somewhere between 500 and 750. Maybe it'd be like 600 or 650. So that doesn't make any sense whatsoever. Not only does it not explain what we want, but it doesn't make any sense based on what the question told us. And then D, the standard deviation is very high. Well, you can actually have a super spread out data set and it still be perfectly symmetrical, and the mean would be equal to the median. So there's my counterexample to that. The spread doesn't really have much to do with the skew, like which way the mean is going compared to the median. Because as you just saw, oh, well, I could have a super spread out data set that's just perfectly symmetrical right down the middle. The mean would be equal to the median. We want the mean to be less than the median. So that's not necessarily the case. So it's got to be A. Great. Let's keep going. Thank you so much for watching, everybody. Please comment below your thoughts on the video and worksheet. Did you find them helpful? Remember to like the video and subscribe for more digital SAT math content. And if you need tutoring, my website is linked in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.